Welcome once again to this class. Today's topic is polynomials. Before we continue to what we have, let us look at our specific objectives. One, at the end of this topic, you are expected to know how to add, subtract a given polynomial. The next one is multiplication of polynomials. Finally, division of polynomial. But our focus here is majorly division of polynomials. For the sake of foundation, I'm starting with addition and subtraction of polynomials. So, a polynomial is an equation whose power is greater than 2. So, generally, polynomial P equals quotient multiplied by divisor plus remainder. General term. For the addition and subtraction, for you to add a given polynomial, their powers must be the same. For instance, s cubed, that's 2s cubed plus s squared minus 5s, and you have q to be this, s cubed minus 2s squared plus x. To add this together, the arrangement must work together. If I have p plus q to give us this 2s cubed plus s squared minus 5s, then plus s cubed minus 2s squared plus s. Where to add, their powers are the same. The coefficient here is 1. 2 plus 1 is 3. So s power 3, that's s cubed. This plus this is minus s squared, minus 5s plus s is minus 4s. So p plus q is 3s cubed minus s squared minus 4s. Why p minus q will give us you have to introduce the minus sign. Here is s cubed. Here becomes 3s squared minus 6s. Both of them, the solution can never be the same because one is plus and the other operator is minus. So this is what you have in addition and subtraction of polynomial, just the foundation of polynomial. Let's go over to multiplication. The foundation in multiplication, you have to know how to multiply two given polynomials. The rule of indices must be followed strictly. Otherwise, you'll be creating another solution thinking you know what you are doing. For instance, if p equals 4s cubed plus 2s squared minus s to be multiplied by this, let's say s cubed plus 3s squared plus 2. Because of multiplication, let me just take two values. In our expansion in quadratic, we're talking about expansion and factorization. When you want to multiply, you want to expand a given thing, it means PQ implies what? 4s cubed plus 2s squared into this, okay? So to make this thing easier for you, just take it one at a go. 4s cubed into s cubed plus 3s squared plus 2, then plus 2s squared into s cubed plus 3s squared plus 2. Now let us work it out. This time this 4s cubed plus 3. You don't say multiply, no. In law of indices, multiplication means addition. This is that addition I'm bringing in now. Then plus 4 times 3 is 12. You choose one. 3 plus 2, okay? Then plus 4s cubed times 2, which is 8s cubed, plus the next 2x power 5 plus 6s power 4 plus 4s squared, okay? So I want to conclude by saying 4s power 6 plus 12x power 5 plus 8x cubed plus 2s power 5 plus 6x power 4 plus 4s squared. Check the ones that are common to each other. You add them together. I don't have power 6 twice, so I'm picking that one. Power 5, I have it twice. So 12 plus 2 is 14s power 5. Power 3, I have it once. Okay, power 4, I have it once. 6s power 4 plus 8x power 3 plus 2s squared. That becomes the solution to that question. That's the solution. Quickly, we are going over to the major thing, polynomial division. Polynomial division. Having gone through your addition, subtraction, and multiplication, let's switch over to division of polynomial. At this time, we are going to make use of what? Examguide. Look at this. The polynomial f of s equals, let me write it down, equals 2s cubed plus ps squared plus qs minus 5 has s minus 1 as factor and a remainder of 27 when divided by s plus 2, find the values of P and Q. Okay, foundation is necessary in this topic. How do we go? Remembering what we call a factor theorem and remainder theorem is also working here. See it, remainder of 27, remainders theorem. Factor theorem is just this. How do you generate factor theorem? You have to recall that in quadratic equation, when we talk about find the equation whose roots are 2 and minus 3. In factor theorem, the numbers you are seeing becomes s minus 2 and s plus 3. I'm just bringing your mind back to root of equation so you can have a sober reflection of what you already know. Bring the knowledge here, apply it. This is trying to make you to know that if you have x minus 1, it simply implies that s minus 1 equals to 0. So that s will be what? 1. And if you're having s plus 2, this simply implies that your s is going to be what? Minus 2. At least you have what you want to do in mind. That's step 1. So step 2, having recalled all these steps, we have the method and the rule. We'll come back to this, meaning this is 2 power. That's 2s cubed. What is the value of s here is 1. You raise to power 3 plus p into 1 raised to power 2 plus q into 1 minus 5 equals to 0. I call it what? Equation 1, but let me standardize it before I name it equation 1. This is 2 plus p plus q minus 5 equals to 0. Equation 1. Bringing them together this way, I have this minus this, which is minus 3. If I transfer, it becomes what? 3. I have settled this gentlemen. Equation 1 settled. Now I want to create equation 2 so that we can proceed to generate our solution. Having been told that s plus 2 is equal to 0, whereby s will be assigned what? Minus 2. So our f of s, 2 into minus 2, power 3, plus p minus 2, all squared, plus q minus 2 minus 5 equals to 27. Why am I writing 27? You were told that it has a remainder of when it was divided by s plus 2. So I have to say equals 27. Then the other one, I am equating to 0 because there was no remainder. When nothing is remaining, it simply implies what? 0. I hope that point is very clear now. Okay. For this reason, here is minus 16 plus 4p minus 2q minus 5 equals 27. We have in here 4p minus 2q minus this is minus 21. That is 27. If I transfer 21 here, it becomes plus 21. 4p minus 2q equals 48. I decide to break down this. I will have this equals 24. I call it equation 2. You can see that the whole thing here is what? Solvable. Now we can proceed to produce our what? Final answer. Let us provide the solution to this question. How do we do it? Having equation 1, p plus q equals 3. Having equation 2, 2p minus q equals 24. By elimination method, you pause. This is plus, this is minus, meaning they are the same. Meaning this will cancel this. So 3p equals what? 27. Dividing through by 3, or you can say multiplying through by the what? Multiplicative inverse of 3p, which is 1 over 3. It will leave us with p being equal to what? 9. So p is who? 9. Solve for q. Solving for q, I can decide to choose any equation of my choice. If I like equation 1, I will go with it. If I prefer equation 2, I will also pick it. Now, my choice here is I want to use equation 1, which says p plus q equals 3. Recall that p is who? 9. Now, plus q equals 3. So, subtracting 9 from where? Both sides. That means q plus 9 minus 9 equals 3 minus 9. Okay, q now equals, because this will cancel this, minus 6. Therefore, p equals 9 and the q equals what? Minus 6. Let's take a look of another sample, but take your time to go through what I've done so that the knowledge will sink well in your medulla. Checking another question. Okay, this is another fine one. But before we proceed, you were told that when this was divided by this, it leaves a remainder of 27. What am I trying to do? You know, our topic is what? Division of polynomial, but this is just one problem in polynomial. So I want to actually make you to know that the division is very possible here. So let me use this same question to do the division we're talking about and see if indeed it will give a remainder or leave a remainder of 27 if it is divided by s, a factor called what? X plus 2. Let's see how it goes. If this is being divided by this is this plus. I recall our p was 9, okay, plus 9s squared, while q is who? Minus 6, minus 5. You were told if this is divided by who? S plus 2, it must give a remainder of who? 27. Then let's see. This is 2s cubed all over s to give us what? 2s squared. All right, 2s squared. This multiplied by this, 2s cubed, multiplied by this plus 4s squared. Okay, I want to subtract. When you do, here we key here will give us what? 5s squared minus 6s minus 5. So all again, 5s squared all over s will give us what? 5s, all right, plus 5s. This multiplied by this is going to give us 5s squared plus 10s all over what? I want to subtract. This will take care of this. This minus this is what? Minus 16s minus 5. So minus 16x all over s will give us minus 16. All right, minus 16. Minus 16 times this, minus 16. Then minus 16 times this is minus 32, abi? Okay, 16 times 2 is 32. Introducing our minus once again, here will give us nil. Then 32 plus minus 5 will give us what? 27. So you can see that indeed when the polynomial 2s cubed plus ps squared plus qs minus 5 is divided by s plus 2, it will give what? A remainder of 27. Another proof here, you were also told that it has one of its factor to be what? X minus 1. How is that true? What do you have here? Good. We have 2s squared plus 5s minus 16, right? Now, I want to create my linking so that I can factorize. This times this is minus 32 s squared. I'm bringing down 2s squared plus, okay, leave this out of it. This is 16, bring it down. What are the two numbers? When I multiply, it will give me 32, but if I add them together, it will give me 5. But I know that 16 times 2 is 32. Also, 8 times 4 is 32. 8 times 4 is 32. That way, it's not going to work for us. 9 times 4 is 36. 16 times 2 is 32. Okay, let's try something here. If this will create a factor. If this is one of the factor of this, okay? X minus 1. Let's look out for something now. This time this is what? S squared minus plus 2s minus s plus 2, okay, minus 2. This is s squared plus s minus 2. Now let's see. If this is divided by this, it's going to create this. Let's see. S plus 2 into this again. This here give us s squared. This time this is 2s squared times this is 4s. Okay. This divided by this, it will give us okay. It will create s, this s squared times this 4s, divide. Here is u, s minus 16. This going again. Plus 1. This time this s. Okay. Let's take another question, and probably we'll take a proper question for division of polynomial to add to this one we already solved, so that the knowledge will balance. But however, we have gotten the values of P and Q, which are what? -6 and 9. The next question here is talking about the polynomial f of s, s cubed plus p s squared. -10 plus q is exactly divisible by what? S squared plus x minus 6. Okay, find the possible value of. As some human being will want to start this way, s this into this minus 10 plus q, something of this nature. Good. If you do, look at where it will land you. So you learn how to factorize by force. See where it will lead you to. S cubed all over s squared. It will give us what? S. This times this. This is s cubed times this. S squared times this minus 6s. Okay? This will take care of this. Now what happened here? That's where problem begins in exam hall. Reason, they cannot communicate each other. P is not a number. It's a constant. It's unknown. Why the coefficient of here is what? 1. Now, coefficient here is P. So how do you add 1 and P together? Do you add unknown to a known value? No. Therefore, this is the wrong method. So look at what you need to do here. Factorize this. When you do, you are going to have minus 6s squared. This s squared, bring down minus 6. What are the two numbers when you do? There are 3 and 2 minus 2. So you can create this. 3s minus 2s is this. This and this will give us this. Meaning plus 3s minus 2s minus 6. All factorize, we have s into s plus 3 minus 2 into s plus 3. Our factors here now are what? S minus 2 and s plus 3, okay? Now, since we have s minus 2 and s plus 3, it simply implies that one of the factors here, s minus 2 equals 0, or the other factor, s plus 3, is also equals to what? 0. So x is either 2 or minus 3. Good. Then pick one of them. When s is 2, this equation becomes 2 power 3 plus p into 2 power 2 minus 10 plus q equals to 0. Equation 1. Forming equation 2, minus 3 cubed plus p into minus 3 all square minus 10 plus q equals to 0. Equation 2. Let's balance them. This is 8 plus 4p minus 10 plus q equals to 0. We balance here. This is minus 27 plus 9p minus 10 plus q equals 0. Now, I have 4p from equation 1 plus q. 8 minus 10 is minus 2. If I transfer, that is 2. I have balanced that one. Then 9p plus q minus 27 minus 10 equals minus 37. If I transfer, it becomes 37. Okay? Now, by elimination method, this goes this is minus 5p. This guy will die. Okay, go. It's not balanced because the signs are what? This is plus, so you can't do that. Now let us introduce a minus sign. Good. When we do this minus this minus 5, okay? This and this, it will die. Then 2 minus this becomes what? Minus 35. Good. Now let us continue with this. This is 5p equals minus 35. Dividing through by minus 5, or you say multiplying through by the multiplicative inverse of p. P is going to give us what? 7. Now solve for who? Solve for q. From equation 1, according to what you decide to do, we know that 4p plus q equals to, at this point, 4 bracket 7 plus q equals what? 2. So that 28 plus q equals to q equals to 2 minus 24, q equals to minus 22. Therefore, p equals 7 and who q equals minus 22. So let us hold it here for polynomial division and a little word problem in polynomial. God bless you once again for being part of this class. Remember to subscribe to our channel while you watch the videos.